This is the second video to demonstrate the operation of RANT. In the first, we saw how to navigate to the Cambridge NDB and enter the hold. We are now approaching the overhead and are cleared for the ILS procedure. Before I let the aircraft run, I'll just sort out a few things. The ILS frequency is 111.3. Next, checking with the Jeppesen plate, I see that the outbound course for a Cat A aircraft is 063 degrees, and that when established on that, I can descend to 1700 feet. The turn inbound is at 8 miles on the DME, and the inbound QDM is 231 degrees. So we'll just set up the inbound course on the HSI. And I know that I'll need to make a drift allowance for the wind. Remember, it's from 330 at 20 knots, and I reckon that a heading of around 053 degrees should just about do it. As we're going to need to alter course by about 30 degrees to the left, I'm going to set the heading bug to 15 degrees beyond that heading, just to pick up the track at a reasonable rate, so that'll be 038. Remember, I can't descend until I'm within 5 degrees of track 063. On the way in, I make any necessary adjustments to maintain this track in the hold, and I know that the needle will drop approximately on the whole minute. There goes the needle. Turn onto the preset heading and wait. Make a radio call if required. Now we have to watch the tail of the needle, and remember, only check the track when the wings are level. Otherwise, ADF dip will surely mess up your calculations. Pre-select the bug to 053 degrees. As the tail approaches 065 degrees, we'll turn right to maintain the course with our 10 degrees of drift applied. Once we are within 5 degrees, we can descend to our platform turn height of 1700 feet. Down we go. The ILS frequency is 111.3, and we can select that now. We have to identify the localizer and DME. Now's a good time. The turn has commenced at 8 miles DME, so I need to keep a close eye on that. As the platform height is approached, I'll level the aircraft. The turn inbound is largely into wind, so I'll pre-select 300 on the heading bug. If you look at the HSI, you can see that the glide path pointer is parked at the top and that the course deviation bar is showing a fly right, as we would expect. When we are in this position, we can select the auto glide path, which will look after the descent profile. When more experienced, you can elect to fly the descent manually. To save time, this approach will be flown at 120 knots. Eight miles showing on the DME, so we'll turn in. Once established on the intercept, you need to decide if you are going to use the heading bug on the final approach, particularly if you have opted in the program setup for the turn to stop on the heading bug. This can become a bit of a nuisance when making small corrections around the datum heading. I prefer to move it out of the way. The final approach QDM is 231 and the wind is from the right, so I reckon a good datum heading will be about 241 degrees. Remember that the wind will back and decrease, and although the auto glide path will take care of the descent, the datum heading will move toward the inbound QDM. I need to intercept the localizer before the final approach fix and join the glide path from below. The ADF needle will give a good indicator of the time we can expect the course bar to come in. Full scale CDI deflection is about 2 to 3 degrees. So when the ADF needle shows about 5 degrees to go, I'll reduce my cut angle to 45 degrees and then turn on final heading as the CDI comes in. Once established on the localizer and the radial call has been made, we need to ensure that descent is commenced at the appropriate place, which is the final approach fix at 5 miles DME. If the auto glide path is not selected, you need to calculate the required rate of descent from the ground speed, set that, and commence the descent manually. The hard work's been done now. Fly smoothly, making very small corrections, remembering that the wind will back and decrease as we fly down the approach. Set up the system for the go-around and always be prepared to carry it out if instructed from ATC or if the required visual references are not achieved at decision altitude, remembering that any turn must be commenced after the missed approach point. Assuming all goes well at decision altitude, the software will give the sign of success. If it hasn't, you can press escape and it will tell you where you went wrong. The next video will cover the DME ARC procedure. If you have found this useful, go to our website at oddsoft.co.uk where you can learn more about RANT.